So welcome everyone. Thank you so much for joining us today. A bit of a different time, as you might have noticed, 10 a.m. Mountain Time instead of 4 p.m. And that has a reason, because we're super happy to have two guys from Germany over at our seminar here. So a bit of a transatlantic seminar this week. Yeah, so thank you so much for joining today. We have Stefan and Ulrich from Bauer with us. They're going to be talking about vertical cutting, cutter mining, crossover technology from civil engineering. And both Ulrich and Stefan I know from my master's thesis 3 years ago now already. So I was kind of involved in the whole space. It's a super interesting technology, definitely something pretty new for a lot of mining engineers. Some might have heard of it, but yeah, cool topic. I'm super glad you guys could make it, and really appreciate you staying in the office a bit longer, or even coming into the office specifically for this. And with that, yeah, we would like to do a Q&A at the end. So if you have questions, we're not a really massive group today. So if you would like to ask the questions personally, just do that at the end of the seminar, or put them in the chat box, and we'll direct them to Stefan and Ulrich. And we're looking forward to have a good discussion and great talk with you guys. So thank you so much for joining, and take it from here.
Good. So also a welcome from us here in Germany. So Stefan and we're going to present a little bit our latest information about vertical cutter mining. Don't be surprised. We are not neglecting any rules. We are sitting in one office, but we are both
having
our tests and vaccinations, Stefan, and so everybody is clean. So don't be surprised that we are both sitting close to each other, but we are not trusting too much the digitalization. So we said we're going to share it from one space, from one computer, before swapping between laptops and getting stuck somewhere in the line. I think we will go through the presentation. If something really urgent comes up, please feel free to ask, or as Lucas said at the very end, we have enough time to ask, go to your questions and explain it more in detail if you like. Okay. So I will try to share. So just checking, is it visible, the presentation? Good, perfect.
Okay.
Good.
Okay, also thank you for joining us tonight or today in your time zone. It's a big pleasure for us to be able to do this presentation for the Colorado School of Mines. And today's topic is the vertical attack, a crossover technology from civil engineering to mining. We will introduce a little bit Bauer now. The Bauer company, as you see here on the front picture already, is specialized also in civil engineering, and this is where the company is coming from. With Bauer, the Bauer AG, the Bauer group of companies, has three segments. One is the construction business, special foundation for piling of high-rise buildings, cut-off walls underneath dams, etc. In the center, we have Bauer Maschinen, the equipment company, who is producing machines for this special foundation topics and related other fields. And on the right-hand side, you see an example for Bauer Resources. They are mainly concentrating on environmental topics. The construction segments, as you can see on the pictures here, left picture is a dam in Germany where it is rehabilitated. The centerpiece is a foundation for high-rise building. On the right-hand side, another nice picture from a very urban area with piling rigs. On the left-hand side, this is the Suez Channel, where a tunnel is built underneath the Suez Channel with the help of the trench cutters, pilings, and dike rehabilitation. And on the right-hand side, I think it's in Bangkok, where we do foundations for high elevated bridges. On this one, you see some key elements of our equipment sector. Left-hand side is piling rigs in all different dimensions, from very small ones for mini piles up to 3-meter diameter piles. Lower picture is then the head of a cutter. This is the topic which we are covering today. And all these machines are also built for low headroom applications, for a cutter, as you see in the middle picture, for a cutter underneath, bridges in underground garages and things like that. The cutter again on the right-hand side, piling on the right-hand side, and in the middle is also some foundation related, but in this case it's offshore piling for wind farm foundation. And on the resources segment, they are mainly concentrating on rehabilitation of polluted soil demolition. In the centerpiece is a very huge project in Oman, where polluted water from the oil industry and from the oil drilling industry is cleaned up in a huge reed bed. Water cleaning up in the center picture, and the other ones are rehabilitation, exchange of polluted soils, and this is the main topic of this Bauer Resources. The Bauer company itself has a very long history since 1790, so about 230 years old meanwhile. It started as a coppersmith in Schrobenhausen. The coppersmith developed into a water well drilling business in the vicinity of Schrobenhausen for the local requirements and demand. And then when Karl-Heinz Bauer took over after the Second World War, he then turned the company into a foundation company. Then we also started the manufacturing, design and manufacturing of equipment. And since the year 2001, now we have a separate leg in the Bauer company, the Bauer Maschinen, which is specialized on manufacturing, designing and selling equipment, basically to all the competition of Bauer. Yeah, in the moment we have around 11,600 employees in about 110 group companies worldwide, and we generate in total a turnover of 1.5 billion euros a year. Our topic is here then to bring the experience which we gained over the last 100 years almost in the special foundation water well drilling into the mining industry. And meanwhile, with all the different legs and the sister companies, we can cover quite a big segment also in the mining industry. We are focusing certainly with equipment for the mining industry, not as, let's say, like Caterpillar or other ones in this big truck and shovel, but on specialized equipment, which is an equipment modified to the requirements of the mining industry. Then we also provide services together with local partners within the Bauer Group, or providing also operational and support for it. And then we certainly also develop methods based on our standard foundation methods, crossover technologies, and then in certain cases we also develop our systems into customized mining applications.
Okay. As a start, we would like to have a short outlook, or what is the current situation of conventional open pit mines, especially for small ore bodies and veins. So not looking into the large scale coal or iron ore fields, it's really concentrating on small ore bodies and veins. The current situation, as an example here on the Scorpion zinc mine in Namibia, is a typical situation which is today seen, and the challenges which is already pointing out is really the major stripping of waste rock to get to the ore, combined with the material holding time and costs, and also, as you can see in the back, the massive waste dumps, which are then for sure required. Such operations really, they cause intensive roadway and bench maintenance, and it's also a big safety hazard to operate such mines with all the vehicle movements and so on. Overall, it's really such open pit operations need extensive planning, and especially for future planning, which part of the ore you want to extract and how to handle the pit wall stabilities. Another topic and a challenge for such a mine for sure is the accessibility of residual ore. As you can see on the left picture, at the moment the mine reached its final pit level, and on the graphics you can see how much ore is still left behind. And most of the time it's either technical or economical, or sometimes both, limit why further pushbacks cannot be made. So it's a lot of money which is left behind in the ground. Another topic for a challenge for conventional open pit mining, as an example on the Diavik diamond mine in Canada, is that to reach the ore body, massive water management is required. Artificial dikes have to be built, water has to be pumped out, and at the very end, it's a clear picture on the right side. What is the strip ratio from waste rock to ore? As you see marked in the red, this is the kimberlite body compared to the overall size of the open pit. As we said before, the accessibility of residual ore is drastically shown on this picture of Diavik, where further pushback is absolutely not possible because the dikes are there, no more pushback is possible. The only solution at this time was to do a cost-intensive underground mine, which you can see on the graphics. But already the third pit, so the current one, 821, underground mine was not anymore suitable due to soil conditions. So again, a lot of material has to be left behind. So overall, as a summary, in our opinion, and I think it's the overall opinion, open pit mining includes high strip ratio. And this results always in a huge disturbance of surface area, movement of waste material, huge mine dump areas, surface water management is required. It's always a huge environmental impact, which results in high cost for land, energy, and equipment. And not last but not least, after the mine closure, it leads to a huge rehabilitation effort. So the target is really to concentrate on the ore body itself. So the request for a selective mining is there.
Okay. And this is now the topic where I want to start here, is the alternative mining solutions. And in our case, the request, as Uli told us, is a selective mining method from the market, an alternative to cost-extensive open pit and underground mining. A reduced environmental impact and environmental footprint is a must nowadays. And also a big advantage or a big disadvantage nowadays is the time to mine, to get until you get to the ore and get the revenue from the mine. And therefore, we working on alternative customized mining solutions. For our topic today is the crossover technology from civil engineering. In civil engineering, construction of trenches for cut-off walls, followed by vertical extraction of material, is a day-by-day business. And in principle, we do the same as we want to do in mining, making slots in the ground and removing, instead of dead sands and gravel and rocks, as we do it in the foundation industry, we want to recover valuable ore. And there we see great synergies between the well-proven Bauer cutter system. I think we have around 400 units working around the world since 30 years now, and the request for an alternative solution for open pit or underground mining methods, especially for smaller commodities. And this is now some introduction about the cutter technology.
Cutting technology is quite now on the market since like 60 years, nearly 60 years, and it started in the early days in Japan with companies like Tone, who really started doing cut-off walls with a type of cutter. In 1984, it was the first Bauer cutter which was introduced to the market and which was used for our own project to install a cut-off wall in a German project for an artificial lake. At this stage, it was completely done within a short period to design, manufacture, and put the rig in operation. So it was a big step for our company, besides being just a construction company, also being an innovative technology supplier. Nowadays, as Stefan said, we have our rigs in all different type of shapes, in all different type of applications worldwide in operation, from underground to standard on-ground conditions, on sea, compact, silent cutters. So there's a huge variety of cutter solutions now on the market. And it also shows the modularity of the complete system. A typical application for cutters is the installation of diaphragm walls or cut-off walls. In this regards, we had before typical projects are rehabilitation of existing dams, or you see on the right, far right, really construction of deep shafts. This was even the top one is a quite new picture from operations in UK, where the top shafts for a huge potash mine are sunk down to a certain depth with the trench cutter technology. Other projects are really construction elements in an open pit for construction in urban areas, or really creating new dams for water management. The heart of the cutter is really the cutter head and the cutter body itself. On this picture, you can see all the major components. Most important are, as you can see on the right, are the two counter-rotating cutter wheels driven by gearboxes, and in the middle section, the submersible pump, which is then transporting the cuttings to surface. The overall process, it's a continuous process and a closed loop. So the trench is always filled with a transport fluid, either bentonite or even for mining, just pure water. And the cuttings are pumped to surface, brought into a separation unit, like you can see on the right picture. The solids are removed from the fluid, and the water or the slurry is pumped back to the trench. And as said, it's a closed loop system. To cover the different applications of the projects, different types of cutter wheels are required. And as you see, there's a huge variety of different shapes and types of cutter wheels, similar to what you might know from standard water well drilling, exploration drilling. There are just different methods, especially relying to the condition of the soil. Is it sandy? Is it gravel? Is it clay? Or is it even hard rock? So different types of wheels are available. And the good thing is these wheels can be exchanged very quickly on site. So with the same basic unit, you can apply different geological tasks. The whole cutter itself, and this is coming especially from the civil engineering, where the verticality is of utmost importance, is completely controlled from the control system, which is called B-tronic in our case, from the operator's cabin, and the steering and control systems on the cutter. So in this regards, there are over the whole length of the cutter various steering plates which keep the cutter in the vertical position and even can steer it in certain deviations. The whole control system is also there to collect the data of your production rate, of your depth, the pressures, and allows automation of the cutting process. Today, nothing is without data, so the whole system also is connected over our data system with the rig, with the office, with the job site, and all the information can be shared to the relevant people and teams. And also the technical support can be given even from our head office. If there are problems, if there are difficulties, we can support and do troubleshooting even into a remote location. One of the big steps forward and one of the most topics to reach a big depth was the development of various hose handling systems. And on the far left, you see a picture quite of the very early days where the hose tensioning system, is how we call it, was limited to the height of the cutter. So in these days, we only could have reached 60-meter depth. But by the development of the hose drum systems, where the pump hose and the hydraulic supply hoses are reeved up in a drum system, we now can achieve depth of up to 250 meters.
One of the new topics which we have to develop, especially, is for harder rocks. Since there we found our limitations in production, we developed the so-called hard rock cutter system. The hard rock cutter system overcomes the problems of a free hanging system, where we have good performance in soils and rocks up to about 40 MPa. But if the rock gets harder, then we have a limited performance. The cutter starts jumping, and this jumping then creates high peak loads on the gearboxes, and sometimes leads to damages or a reduced lifetime. Therefore, we now have developed the so-called hard rock cutter system, basically a box filled with hydraulic and plates, and the plates lock the lower part of the cutter in the trench, and then with a hydraulic cylinder system pushing the cutter head forward, we can produce a constant load on bit and reduce the peak loads with the system. So once again, we have a standard cutter frame. In between the standard cutter frame and the standard cutter gearboxes, we have now included this HRCS system, the hard rock cutter system. And with this one, we can activate significantly more pushdown, up to about 140 tons. We have a modular intermediate frame. The push-out cylinders pushes these plates to the sidewall and basically locks the cutter into the sidewall. And the thrust cylinder, as mentioned, have the capacity of up to 140 tons. And then they are also stabilizing the cutter inside the trench to avoid this jumping cutter. And then we have developed an automated system that brings the performance of the cutter, even in hard material, up to a maximum by automatically locking the system, pushing it forward, and then after a certain step parameter of about 1 meter, the cutter is left free and moved down and then locked again. So this whole process is meanwhile automated. Once again, this system is very much required and of a big beneficial for operation in hard rock, especially using roller bits. As on the left-hand picture, you see a picture from 1990, where we already started in the application of roller bits for a very hard rock dam in Japan. but overall the system was not very successful. We also used this system for grinding hard materials and boulders on the direct project, but for a large-scale operation and for a large-scale application of the roller bits in harder rock, it was required to develop this hard rock cutter system. And especially then, as we can see later on in mining, where production is of most importance to the mining industry, the system will give us a much better production and advantage to use the system of a cutter also in hard material.
This was then the stage, as Stefan just said. It's for us, the limiting factor was always the constant weight on bit and the stabilization. And in this regards, our engineers were how to say, confident that higher production rates can be achieved. But also during this design phase, we got involved together with the Colorado School of Mines, where we had Muthu and Dr. Jamal luckily on board, and where we started to do the simulation of the systems to get more confidence and also backup for our ideas. And in this regards, both type of cutter wheels, what are mostly used in hard rock cutting, like the pick teeth cutter wheels and also the single disc cutter wheels, have been modeled or remodeled by Colorado School of Mines to put it into their simulation system. So you can see on the graphics, like every pick, every teeth is positioned, and then they ran certain simulations to find out more about the cutting. Additionally, the whole system was calibrated to the actual rates what we got from existing job sites. So we were using our performance data from civil engineering, and Colorado School of Mines included this as a calibration system. Also, we were in the lucky position of Colorado School of Mines having a huge experience on underground mining systems and tunneling. So both sides put in all their knowledge and upgraded this modeling to come up to certain conclusions. And as you can see, for us, the parameters for the simulation had been on one side, the footprint of the cutter, the installed power, for sure the torque, what we can apply, the maximum thrust, the RPMs, and which is the most important is related to the compressive strength. And the good thing is the result, which is proving all our ideas and which is proving our way forward. And what you can see on the graphics is, for example, when you compare the left side pick teeth compared to disc cutter wheels, when we look at round about 40 MPa, the production rate is more or less the same of a pick teeth and a disc cutter. But if it really comes to harder, up to 100, 120 MPa, pick teeth, no more real performance. And with the disc cutters, we still have really huge performances. And this is where, for us, the breakthrough in the whole system is that in combination with the hard rock cutter system and the disc cutters, we can do the step forward to a mining system.
Now let's talk about the cutter for the vertical attack. Okay, as mentioned before, this cutter system has been developed now and in use for 30 years. And in the meantime, the cutter has been also applied on several bulk sampling projects and trial mining operations on and offshore. And by optimizing the system for higher productivity in mining, we think we can make a significant contribution to a sustainable mining environment. And also for mining, we have already worked on various mining projects for the last 10 years. And we have also quite a few patents meanwhile on the vertical mining technology, on the hard rock cutter, on a floating barge system, etc., which are specifically for the mining industry. Where do we want to use this cutter system? The specific use of this system is for small bodies. So as Uli mentioned in the beginning, we are not targeting large-scale mining operation for iron ore and coal. We want to concentrate on small ore bodies where normally the stripping ratio is very high. We want to concentrate on residual ore bodies in open pit mines, which are coming to the mine life end. And also especially we want to concentrate on coal, on seams and veins, which are popping out to the surface, and where we then, with the cutter system, intend to mine out up to a depth of, in the moment, 200 meters, and the future will bring certainly greater depths to the system. We have done some studies with the University of Delft to see which commodities are suitable for this type of excavation. And we see, once again, small kimberlites and kimberlite dikes and pipes. Also, coal is very interesting to us, the metallurgical coals, coal seams, as they come out of the ground in British Columbia quite often. And also in turbidite-hosted vertical or near vertical gold veins, the application is very interesting to us. There are other commodities and ore bodies like uranium comes up in sometimes in hydrothermal veins, some diamond sedimented pockets, gold, and also rare earths, but the upper 3 or 4 are the main focus of our work. On the right-hand side, you see a mine in Canada with a mined out kimberlite pipe, where we could use a cutter because of the small footprint of these units to mine out another 100, 200, 250 meter. And on the right-hand side, you see a gold vein in Argentina, where we can see later that it might be a very good idea to avoid the high stripping and go from the top.
Looking into application trials and projects of cutter mining and what we did already, what we are planning for. Starting with one of our most recent projects is for sure the cutter bulk sampling. What we did and are currently still involved in is for the Rio Tinto Falcon project in Saskatchewan. For us, it was a big challenge, especially due to the geology. In this regards, we had about 120 meter soft soils as a cover before we were able to hit the kimberlite, and there were further 130 meters of kimberlite to be excavated. In this regards, having really a bulk sampling tool, or even a huge bulk sampling tool, we were using our cutter with a size of 1.5 by 3.2 meter. And in total, we were really doing enormous excavation down to 250 meter depth, which was, even at this time, we reached the world record of cutter applications. In total, we were able to provide to our client, which is really showing the size of the bulk, 1,200 cubic meters of soil per trench. And on the next pictures, you can see right at the top how big then the storage for bulk sampling bags has been. So I'm pretty sure that the local dealer of bulk bags really did a good money on this project to sell these big bags. Nevertheless, you see still having, if you look on the big picture, looking at the size, it's in our opinion still a compact piece of equipment if we look into the depths we can reach. A further project, what we did in the past was a dike trial mining for kimberlite for Koidu Resources in Sierra Leone. And it's a huge and a very long kimberlite dike. And the big difficulties for standard mining is that it's really, the host rock is massive granite. So standard open pit mining at this location was not applicable. And we did several tests over a period with our standard cutters on such a project, on this project. As Stefan mentioned before, a possible application is really the near vertical gold veins. Like you can see here a picture from Sierra Vanguardia in Argentina. The vein is very limited, where we say sometimes only about 2 meters thick, and a huge open pit mine and a huge stripping ratio is required. And if you see on the right picture how many of these veins are splitted all over the project, the application of a cutter system is really very close to having a big step forward for a future method. A similar task is also, like Stefan said before, the coal seams typically now close very vertical in British Columbia, where it's really the high price metallurgical coal, where it really makes sense to spend the money, and where at the moment really permitting will become an issue with the authorities. Because as you see on the right picture, to get access to these vertical mines over a huge distance, complete mountain massives have to be removed and then later again backfilled. And as you can see, it's really nice seams, nearly vertical, which can be easily attacked with a cutter system. So more or less, these big V-shaped pits would be avoided in future if cutter mining can be applied here. Another topic is really the taking out the residual value on ore. Here was a huge test what we did for the Ekati mine, where we placed a standard cutter which we were using at this time the year before in Diavik, and we moved over the winter road to do trials on cutting with water in kimberlite. This was the main application, how to see how the cuttings look like, what is the production rate, how does it work out when we cut with water only. And again here, there are quite a lot of diamond mines or open pit mines with this type of ore bodies, which have a mine life which will end in the near future, let's say the next 5 to 10 years, where still a lot of residual ore will be left behind, if not further technologies will be used. And you see on the right side what will be this plant pit shape, and the big yellow cake is left behind, and this is what we try to attack in our daily tasks.
All to this mining, we have to develop a mining sequence, since the cutter is only cutting vertical trenches, single trenches of a size of, let's say, 2 meters by 3.2 meters. So first of all, we have to do single bites, which go down to final depths. And then on the right picture, you see that you can do then intermediate bites. So you can open up, depending on the stability of the ground and of the rock, you can open up longer and longer panels. And yeah, depending on this second step, you then can go ahead with even longer panels on the left-hand side. And then the next step comes into the play, backfilling this trenches with paste back material, with cemented paste back, and then doing, as we can see on the right hand side, cut perpendicular to it and mine out step by step more and more material. And okay, in the ultimate solution, you can mine out almost 100%, but there is always an economic limit, how much you can mine out or you want to mine out compared to the effort of this paste back operation. Especially for veins, gold veins, etc. The backfilling is depending on the width of these veins, not a very big issue, since you open up longer trenches with primary and secondary bites, and basically you leave the open trench behind, as for safety reason, you just backfill it with coarse waste rock. The cutter can work either on one side of the trench and jump back and forth a little bit, but it's always working on solid ground here. And on the other option, if you have, let's say, wider trenches of 2 meters, the cutter can sit also on the rectangular to the vein, and the cutter just moves in one direction, sitting on the still filled vein ore body, and there is no safety issues for the cutter to be buried in such trenches. The next step towards a removal of 100%, especially in, let's say, pipes, is then to flood the pit to a certain level, let's say 5 or 10 meters, and then use a combination of a cutter mounted on a barge system and a hydraulic grab system also mounted on a system, and then you mine out either in layers of 5 or 10 meters, or then depending on the rock quality, you can mine out with single bites down to the very end. On the right-hand side, you see a cutter here on a shallow application in Germany, where we have here, the yellow piece is a trench cutter, a perforation cutter, as we called it in this case. And attached to the cutter itself is a hydraulic grab for excavation of the material.
Having this in plan, and it's not just a wild idea, quite one of our first mining cutters was a floating cutter. And this is a project which is quite some times back already. It's more than 20 years ago, where we were doing offshore cutter bulk sampling outside on the coast of Namibia, where we were using a cutter system which was more or less a standard cutter in-housed in a special frame, where we do bulk sampling on the seafloor. Typical application for such could be that on the one side you can do on the left picture right from the sea level without any water management and dewatering, or as Stefan said before, do a certain flooding of the pit and install it on the pit bottom. Here a picture what we saw before, and as Stefan said, either in full depth or layers it can be mined. A further application is, and this is what we are studying and studied together with NAMDEP, was the mining of alluvial diamond at pocket beaches. And you can see on the left picture, normally a huge seawall is put in place, and then the mine is dewatered. But the big risk was always due to the rough sea conditions. Several times the seawall broke and got flooded pits. In this regards, it's really the idea to have a small seawall, keep the water inside, and then using a floating cutter system, so-called a mine sweeper, to take out the gullies and the pockets full of diamonds. And this is on the left bottom picture. You can see how the typical seafloor looks like. And this is where the cutter would get into for excavation. Quite a step forward and a step deeper is the future application of deep sea mining. And this is also where Bauer is currently heavily involved in certain projects and studies, that we can do deep sea mining up to a water depth of 4,000 meters. For sure, in this regards, it will not be any more pumping. You can imagine we cannot pump up the material down from 4,000 meters. In this is regards, you see on the right picture, there is like a transport container on top of the cutter, where the cuttings will then be lifted to the support vessel and lowered again, and mining can continue.
So let's see what we have in mind for the future. So if we have a project, we have to do a quite intensive analysis of the job site. Then we normally propose a certain trial mining operation, where we specify equipment configuration based on our standard equipment. Then we do a trial mining, And with the result of the trial mining, we then review all the wear and tear characteristics, the ore quality, the trend stability, etc., etc. And then we design equipment which fully fits to the purpose of a certain mining scenario, of a certain mine. The next step where we see major development is the full electrification of the complete mining system. We want to certainly increase the production rate, especially in hard rock. We want to fully automate the cutting process. Digitalization is certainly a big topic also then in mining, to collect all the data and additional data for the geologists and maintenance engineers, etc. And then once again, as said, we want to customize the system to each individual project as required. This is what we have in mind for the future. The target is about 2025. We want to have a cutter which can excavate 100 MPa rock at 6 meters per hour. That means approximately 100 tons per hour. Cutter dimensions would be about 2 by 3.2 meter. We would have a double pump system, the hard rock cutter systems, and since we want to cut 600 MPa rock efficiently, automatic cutted, very different cutter wheels. Once again, we want to have a compact system, crawler mounted, and instead of the hydraulic hose band, which is limiting certainly also the capacity of the mining heads, we want to use, as mentioned, the electric umbilical with a total electric power installed of about 2 megawatts. We then further need to develop a launch system, especially for the inclined veins and dikes. As you can see here, we have already a few concepts in mind. We will increase, as required, the cutter size to a twin cutter frame, for example, where we then can double the production. Or we develop special underground systems to mine out underground veins and dikes.
So the question is, like overall, is the vertical attack a sustainable mining solution? In our case, it's really, especially if we concentrate on, as we concentrate on the ore body itself. So it's really a selective mining. Nevertheless, the rig also has to come with optimizing of the entire mine infrastructure. So it's especially for new future mines, it helps to reduce the overall development costs, because you don't need the huge, massive process plants. You just have to build, related to the mining tool, the adequate process plants. You will have reduced manpower, so less flights to site, less camps capacity, and the overall equipment on site will be reduced, as, for example, the holing process will not be necessary because you could pump straight from the cutter to the process plant. Additionally, minimum environmental impact, and especially for future mining, it's for small ore bodies and remote locations, it's ideal. And it gives you the, due to the modularity of the system, you can move it from mine, from area to area with small modifications only. So overall, I think we spoke most of the topics we already mentioned before, but just to mention it again, it's really, before there were uneconomic small ore bodies which can get viable. The stripping ratio is almost 0 to 1, especially the time to mine is very short. So you will have for your projects very early income into your pockets, and start with the minimum pre-stripping at site, almost immediate revenues said before. Minimum dilution of ore, which helps again in the process plant. You go straight to the high-grade ore. You can extend your mine life. You have low or no additional environmental impact, especially the reduction of rehabilitation costs. And by this, also the acceptance by authorities and public. And in our opinion, all these facts really prove that a vertical cutter mining system is a sustainable mining system for the future.
Yeah, this is the end of our presentations. So thanks for listening, and we are open for questions now.
Awesome. Thank you so much, Stefan and Uli. Really cool presentation. And I like there was a few new things I haven't been aware of sprinkled in every now and there. So it's
you were 3 years gone.
a lot of stuff happens. Really cool stuff. I really like it. We've got a bunch of questions. If there's people who would like to ask questions directly, please feel free and unmute. Otherwise, we'll just go through the ones we have gathered so far. I always like to have a bit of a discussion and have it interactive. That's kind of the beauty of this format. So please feel free to ask directly.
Very good presentation. Just one thing, you have a nice model right behind you. Can we get a copy of it in our office?
Yes, you get.
Yeah. then you can do even better simulation, Jamal.
There you go. You can show it to the students right away.
Okay.
Well, I mean, if no one wants to ask directly, I can just take a few. So the first one we got here is from Dave. He was asking about, so I'm just going to read out the question. How is the soft near surface ground stabilization to allow for recovery of depot ore? Have you had problems with the cutter getting stuck? And then also, how would you recover the cutter?
Okay, one main topic, especially for the Falcon project for Rio Tinto, was certainly the stabilization of the upper 100-120 meter in very difficult loose ground conditions, loose sands and cobbles and boulders and clays. So we had very difficult conditions, and therefore we used for this trench excavation a bentonite slurry to support it, as it is a standard in civil engineering. And so far, the first 10 trenches went without any collapses or burying cutters, etc., which is normal in civil engineering, but it needed some convincing talks to the mining industry that they were really prepared to apply these bentonite slurries in this difficult and very deep trenches up finally down to the 250 meter.
Cool. The next question was pretty similar. The wall stability of the cutter in the rock, you basically addressed that with primarily bentonite slurry. Is there any thoughts of like artificial support installment, anything like that? Would that be feasible?
I mean, this is also the rock stability goes in line with the excavation rate. Now, for sure, if you have very loose material, that you cannot think of full excavation rate. The distance between the trenches will need a certain distance. The big advantage of us is we are cutting individual trenches. On the other side, this comes then in line with the possibility to do a floating system, even in very soft conditions, like in kimberlites, which sometimes are very soft, like clayish, even 5 MPa only. Then the floating system adds the big advantage that you mine out layers and are not standing on the ground.
So may I ask a question, Lucas?
Yeah, sure, go ahead.
Hi, I'm Priscilla Nelson, a professor here, but I'm actually a civil engineer by training, and it's great to see Bauer move into this. Got a question though, 2 things. One is has to do with the weight, the downforce. And in some cases, people have used sidewall gripping to be able to increase the downforce, or putting dead weights on, actually to increase the vertical thrust. So I wondered about that, and also whether you've thought about doing some pre-grouting for the overlying soils to actually stabilize them to a adequate strength and reduce that risk of collapse.
Okay, in civil engineering, especially if you have very weak soils in the top layer, you do some stabilization. In Falcon, for example, we did cutter soil mixing boxes around the starter trenches down to about 15-18 meters. But further down, where you can then guarantee the overpressure inside the trench, there you cannot work only with, let's say, with bentonite slurry in this case, because other grouting methods, especially if you then go into the mining, you spend too much money in grouting the soil before you then excavate the ore, which is not economically. So
what about the downforce? Increasing it so you can go to harder rock?
Okay, this is what we have shown you before. We have certain limits with the free hanging system and the capacity of the base machine. So on this machine in Falcon, we have a limitation of 70 tons. And with such a hard rock system, we certainly then can increase the weight on bit to about 100, 140 tons, which gives us much better performance, as we discussed in with a free hanging system before.
And it's not just the downforce, it's also for us the big benefit in a constant operation is really the locked cutter in position. So you can have really a controlled push down force. And this even is ideal then for wear and tear, for your production rate, really for predictable maintenance and so on. So it's also possible not only for hard rock, it's also for certain rocks, maybe not loose sand, but but it does not need. But nevertheless, for us, it's a step forward to avoid these high, massive loads on the cutter itself.
Great questions. Thanks, Priscilla.
Lucas, Herman Grutter here from SRK. Can I ask a question, please?
Yeah, sure. Go ahead. Shoot.
Stefan and Uli, great presentation. Thank you very much. We've been watching cutter technology here at SRK for a while now. One of the questions that comes up with in the mining application, let's take the metallurgical coal example from British Columbia.
Yeah.
Is if we assume that the strip ratio there is 4:1,
Yeah.
and you could mine that kind of stuff to say 200 meters depth.
Yeah.
Do you believe you will be operationally more efficient than current truck and shovel operations? So in other words, is your operating cost competitive with the current diesel powered fleet?
I think for metallurgical coal, we certainly need a certain value in the ground. If we only talk iron ore and things like that, even the iron ore is in the moment, the price is very high, but we need high value ore. And I think we did some studies with Anglo Coal, where we said this scenario of a vertical cutter mining extraction could be definitely economical. So we have done some study with real projects, and I think overall it can be turned into economical system, and
but as of right now, nobody's actually employing you to mine anything with a vertical cutter. Is that correct?
Yeah, okay. We are working with a few companies in this direction, but as you know, the mining industry is also a very conservative industry, and they always want to wait until someone has proven the system. And I think with this Falcon project, we have shown the industry that we can excavate down to 250 meters, that we excavate also not only soft material, but also harder material. But especially in the coal, where we have normally a compressive strength of 20-30 MPa, cutter excavation with a big cutter, let's talk about 2.5 by 3.2 meter, can be definitely economical.
Yeah, so that's the coal example that you used looks to me like, you know, one of the places you could be competitive.
Yes, definitely.
And you know, it's just it's interesting that the mining industry has not yet adopted your way forward.
Okay, this is not also these vertical coal seams are not very common in the coal industry. We have this very specific cases in British Columbia where we have a row of mines, but the rest of the world is normally let's say, horizontal coal, be it then in open pit like in Australia, or then underground mines with all these proven technologies available. But we are working towards this to use the cutter in the coal, especially also in British Columbia.
All right, interesting. Thank you.
Okay, welcome.
Just one thing I would like to add at this stage is, I think even up to now, for us, where we see now a huge application is really this typical gold veins, where we really talk about hard rock. And we have to accept that up to now, before we have the hard rock cutter system, we were limited. So our production rate was sufficient for civil engineering, where you talk about rock embedment, but where you're not talking about how many 100 tons an hour you can produce. Yeah. So, but now with this step forward, in combination then that we can apply the hard rock tools like the single disc wheels and so on, we are now really a step forward. And to be honest, this change only came in within the last year. So this hard rock cutter system, the study is really recently. So it's quite one of the first presentations where we show our hard rock cutter to the public.
Thank you so much, Stefan and Uli. We're approaching, or we already passed the hour. If you got a minute, we got one or two more questions that you might want to answer. But I would just like to take the time again and say thank you for you guys joining. It's awesome to see that you just go the extra mile and come in at the late hour. And also from a personal perspective, it's super cool to see that you have been so successful in the past 3 years since I finished my really small study on that, and it's really good to see that stuff like this is going on. And to Herman's comment that no one is currently using it, or at least not that we know of, from Bauer. Hopefully this kind of helps too, right? We can spread the message. People need to see it. I think it's, like I said, it's a really unique type of technology, at least for mining until now. So I think this kind of push towards using it is actually the hardest part. So hopefully we're gonna see some more interest in the coming years. And Muthu and Jamal are certainly doing a great job to promote that. So long talk. Thank you so much, Stefan and Uli, for the time. If you've got a minute and you want to stay on for 1 or 2 more questions, then that will be awesome. Otherwise, thanks everyone for joining.
Thanks a lot, Stefan, and really great presentation.
Thanks a lot to everybody joining us today, tonight. I don't know where.
This morning.
This morning, I don't know where around the world. And whenever there are questions, please feel free to give us a call or send us an email on LinkedIn, on WhatsApp. There are a lot of opportunities to get in contact with us. And then we hopefully can develop your projects, your ideas further to use this cutter technology in the near future as a mining tool. Thanks very much to all of you.
Perfect.
Cool. The one question I think was about the vertical degrees you can drive the cutter. I think that was relating to the launch system, especially for veins. Is there some sort of limitation, I guess? On the
okay, once again, there is also now the advantage with this hard rock cutter system. We lock it in, and because if you have an inclined vein, the weight on bit reduces by the inclination. And now with the system, we have a certain advantage that we, even if we have inclined veins, we can push forward actively and overcome, I would say, 20 degrees or something to the vertical. This is where we want to start with, let's call it around.
Sounds good. People are asking for your contact details. If you want to put your email address in the chat box, I think that might help.
So the email address is simply stefan.schwank@bauer.de for Germany, or Uli Schöpf with OE @bauer.de.
Perfect. Yeah, and the last question we had about maximum depth that can be reached. I think you've mentioned that 250 meters currently.
I think at the moment it's the 250 meter, but this is also why we push in our company forward the electrification, because let's say with hydraulics, for sure, we have 250, 300 meters really the maximum of being ideal. And this is why electrification will go forward. And on the other side, this is where you see when we go into deep sea mining, this is a full electrical system, has to be, we talk about 4,000 meters depth. So for us, it's really for the near future, and this is not really in the far end. For us, we really say within the next 4 years, we want to have really a fully electrified equipment, and then bigger depths can be achieved. I mean, we talk about 300, 400, 500 meter where it becomes really then a deep attack.
So the limiting factor primarily for depth is at the moment the hydraulic system.
The hydraulic, and in this regards also the pumping, because as you saw, all the material has to be pumped to surface, and for a certain depth we already use 2 pumps in line, which were, for example, at Falcon. And all these steps we are currently working in how to increase the depth capacity.
Is there any structural limitations of the crane unit at some point, or you?
Okay, the crane has a certain capacity, but I think the depth is not the leading factor for the capacity, especially now with the hard rock system where we don't need that much weight on the cutter anymore.
So we can build lighter cutters, yes, and therefore increase the depth without changing really the base carrier.
Makes sense. Yeah, that's all the questions I have in here. Again, thank you so much for joining.
Okay.
The recording.